Hadoop MapReduce 1.0 version. So, MapReduce is an execution engine of Hadoop, and we are going to briefly describe Hadoop 1.0, its components, that is MapReduce, which runs over HDFS. So, MapReduce is the programming paradigm of the Hadoop system for big data computing, and it also performs in MapReduce version 1.0 the resource management and the data processing aspects also, which runs over HDFS 1.0. So, we are going to cover this Hadoop or a MapReduce 1.0 version in a brief. MapReduce has two different major components. One is called the job tracker, the other one is called the task tracker, and the scenario of the job tracker is you can see here in this particular diagram. So, this is the job tracker, which is a part of MapReduce version 1. Now, this particular job tracker runs on the master, or this is the master node. So, this master node and this name node is a part of HDFS 1.0 version. So, both of them may reside on the same machine or may not be in the same machine, but for the sake of simplicity we assume that the name node and the job tracker resides on the same node, which is called a master over here in this particular scenario. Since it is having a master and several slaves, so hence this is basically a client server architecture, which is followed in MapReduce version 1.0 and also in the HDFS version 1.0. So, in this particular diagram we can see here the job tracker resides on a particular node, which is basically the master node, and on the same master node let us assume that HDFS name node is there. So, we are not going to refer in this part of the discussion. Why? Because we are focusing only on the MapReduce. So, hence we are not going to discuss this name node part of HDFS. Now, another component is called the task tracker. The task tracker may resides on the same node, also resides on other different slave nodes. So, the job tracker and task tracker they run in the form of a client server model. So, job tracker is basically running as a server, and the task trackers is run as its client. So, it is a client server model. Let us understand more into the functionality of job tracker. So, job tracker, as I have already mentioned, is hosted inside the master and receives the job execution requests from the client. So, the client or the application, which basically is nothing but a MapReduce program, when it is submitted by the client, then the job tracker has to deal with that particular program execution. So, its main duty is to break down the receive its main duties are to break down the received job, that is the big data computation specified in the form of MapReduce jobs. And this particular MapReduce is divided into the smaller chunks, and that is the small parts, and these small parts that is called chunks are allocated with the map function and map and reduce function, and this particular partial computations are happening at this particular slave nodes with the help of the task tracker. And this is the entire unit of execution of this particular job. So, let us see the more detail of the task tracker. So, the task tracker is the MapReduce component on the slave machine, as there are multiple slave machines as we have shown here, 5 of them. So, many task trackers are now available in the cluster. Its duty is to perform the computations which are assigned by the job tracker on the data which is available on the slave machines. So, the task tracker will communicate the progress and report the result back to the job tracker. The master node contains the job tracker and the name node, whereas all the slave nodes contain the task tracker and the data nodes. So, in this particular way, the job tracker keeps the track of the map and reduce jobs which are being allocated at different nodes and which are executing on the data set which are assigned, which are allocated to these particular nodes where the data is there, the map and reduce function or the computation will be performed. So, it is a computation engine. So, MapReduce is a computation engine in version 1.0. So, not only it allocates the MapReduce jobs to different slave nodes where the data also resides in the form of a chunks, and it will then collect. And so, basically not only it assigns, but also it keep track of the progress and the resources which is being allocated. वो क्या हो गया, चला गया क्या, डिस्कार्ड हो गया तो फिर से करना है, छोड़ दो. The execution steps. So, we are going to now trace all the execution steps for the life cycle of a MapReduce job till the application is submitted by the client and to the MapReduce, and it finishes, and we are going to trace the execution cycle or the execution steps in the MapReduce version 1.0. So, the first step is the client submits the job to the job tracker. For example, here we have to find out, we have 20,000 records of the customer, and we want to find out all the customers from Mumbai. So, that means the query is basically to be executed on this data set, and this particular operation to find all the customer, this is the query which is to be performed using the MapReduce program which is being submitted. So, this particular request is being submitted to the job tracker, and job tracker will ask the name node about the location of this particular data set. So, the job tracker will consult the name node which is a part of SDFS to find out the location of the data where it is being stored. So, let us say that this 20,000 records are divided like this. There are 5 different nodes which stores all of them This is node number 1, 2, 3, 4 and 5. So, the records first 4000 records are stored on this particular node number 1, and the next 4000 is stored on the node number 2, and then next 4000 node number 3, and furthermore node number 4 and 5 respectively stores the remaining 20,000 records. Now, this is called the chunks or the splits. The entire 20,000 record is splitted and is stored on 5 different nodes, and this information will be given from this name node back to the job tracker. Now, the job tracker, as per the reply by the name node, the job tracker asks the respective task tracker to execute the task on their data. So, therefore, this particular job tracker now assigns the map function or map and reduce function on this task tracker to execute on that data chunk. So, with this particular direction, the task tracker will perform this execution at all places that in parallel. So, this particular execution of MapReduce program is done in parallel on all the chunks. So, after the computation of a MapReduce, so all the results are stored on the same data node. So, whatever is the result it will be stored on the same data node, and the name node is informed about these particular results. So, the task tracker informs the job tracker about the completion and the progress of these jobs assigned to those job tracker. Now, the job tracker informs this particular completion to that particular client, and the client contacts the name node and retrieve the result back. So, after completing it, this particular job tracker will inform to the client about the completion of this particular job. That means, now the result of the query is now ready, which the client will be able to access with the help of name node and gets back the result. So, this is the entire execution engine of which is there in the form of a MapReduce version 1.0 that we have briefly explained. Thank you.